Okay, hi guys. So in this lecture, we'll be discussing series and parallel reactions in first order kinetics. Series and parallel reactions or first order kinetics. So first, let's see parallel reactions. So let's suppose A gets converted into B and C. Initially we had 1 mole of A, so now X moles of B is formed and Y moles of C is formed. So concentration of A, or the number of moles of A remaining, would be A minus 1 minus X minus Y. Similarly, if we have A as the initial reactant, B and C are formed, rather 2B and C are formed. So from A, let's say X moles of A decomposed into 2B, so 2X moles of B would be formed, and let's say from A, Y moles of C was formed. So again we would have the final number of moles of A would be A minus 1 minus X minus Y. So in this case, total moles would be moles of A plus moles of B plus moles of C, which would be nothing but 1 minus X minus Y, plus MB would be X, MC would be Y. So we would be getting 1. Okay. And here we can write that after completion of reaction, let's say we don't have any moles of A present after the completion. So 1 minus X minus Y, which is the moles remaining of A after the completion of reaction, is 0. So we can write that X plus Y would be equals to 1. Okay. And when we talk about this reaction, then after the reaction, as we already know that A would be finished off after the reaction, so 1 minus X minus Y would be equals to 0, or we can write that X plus Y would be equals to 1. Okay. And as X plus Y is equals to 1, total moles remaining after the reaction, would be moles of A, which is A minus X minus Y, which is nothing but 0, plus moles of B, which is 2X, and moles of C, which is Y. So we would have total moles as Y and Y get cancelled out, 1 plus X. So total moles here would be greater than 1. Okay. So these two are different situations that may arise. After the completion of the reaction, total moles may be equals to 1 or greater than 1. Okay. And let's say we have another example, another parallel reaction in which we have A dissociating into 2B and 2C. Okay, let's say X moles of A converted into B, so B would have 2X moles, and Y moles of A converted into C, which would have 2Y moles. So after completion of reaction, we know that A won't be present in the mixture, so the moles of A would be 0, which were equal to A minus X minus Y, or 1 minus X minus Y. So X plus Y would be equals to 1 here. Okay. and after how many total moles present after completion. So total moles are present after completion, let me write total here, would be equals to moles of A plus moles of B plus moles of C. That would be equals to, moles of A is 0, but again we can write A minus 1 minus X minus Y. Moles of B are 2X, moles of C is 2Y. So we can write it would be 1 plus X plus Y, and X plus Y is 1, so it would be 2. So the number of moles present after the reaction were double the number of moles that were present at the initial point of the reaction. Okay, so now let us generalize this into saying that A gets parallelly converted into B and C, and let's say the conversion constant, rate of conversion constant was K here, and K1 was rate constant of conversion from A to B, and K2 was the rate constant for conversion of A to C. Then we can write that K would be equals to K1 plus K2. Okay, so we'll be seeing more on the calculation part and the derivation part of the parallel order reaction, means the kinetics of parallel reactions, in the next lecture. So till then, good luck and goodbye.